When we look at the night sky, we see a structured universe. Stars, planets, and galaxies all seem to follow a predictable order, held together by gravity. Most black holes we know follow this rule. They're either at the center of a galaxy or part of a star system, orbiting a companion. But there is another type of black hole that defies this order. They're called rogue black holes. These are massive objects, often several times heavier than our Sun, wandering through the darkness of interstellar space. They're not attached to any star or galaxy. They are alone, invisible, and moving at incredible speeds. Scientists estimate that there are over 100 million of these rogue black holes in our Milky Way alone. Despite their high number, they are nearly impossible to find. They don't emit any light, and because they are not feeding on nearby stars, they don't produce the X-rays that usually give away a black hole's location. They are like ghosts traveling through a dark ocean. Why are they moving? How did they lose their homes? And most importantly, what would happen if one of these invisible giants entered our solar system? In this video, we will break down the science behind these cosmic wanderers. We'll look at how they are kicked out of their birthplaces and how modern technology is finally allowing us to see the invisible. To understand what a rogue black hole is, we first need to look at where we usually find them. Most black holes that scientists study fall into two main groups. The first group is supermassive black holes. These are the giants that stay at the center of galaxies. Our own galaxy, the Milky Way, has one called Sagittarius A star. These black holes don't move much. They act as an anchor for the stars around them. The second group is stellar mass black holes in binary systems. These are smaller black holes that orbit a normal star. We can find these easily because they pull gas from their companion star. This gas heats up and glows brightly in X-rays, making the black hole visible to our telescopes. However, a rogue black hole is different. It is unbound, meaning it has no home and no companion. It wanders alone through the empty space between stars. Because these black holes are alone, they have nothing to eat. Without a nearby star to provide gas, they don't create a glowing disk. They don't emit light, heat, or radiation. They are completely dark and nearly impossible to see against the black background of space. This is why scientists often call them the ghosts of the universe. So how many of these invisible objects are out there? According to scientific models and recent data, the numbers are shocking. Astronomers estimate that there are about 100 million rogue black holes in the Milky Way alone. To put that in perspective, our galaxy has about 100 to 400 billion stars. That means for every 1,000 stars you see, there could be one rogue black hole hidden in the darkness nearby. Even though they are many, space is so vast that they are spread very thin, making them very hard to track. These rogue objects are usually the remains of massive stars that died long ago. When a star much larger than our Sun runs out of fuel, it collapses and creates a black hole. While many stars stay in their original systems, some are kicked out into the void. For a long time, these were just a theory. We knew they should exist, but we couldn't prove it. That changed in 2022. Using a technique called gravitational microlensing, NASA's Hubble Space Telescope finally confirmed the existence of a rogue black hole. Microlensing happens when a black hole passes in front of a distant star. The black hole's gravity acts like a magnifying glass, bending and brightening the light of the star behind it for a short time. By studying this light, scientists can calculate the mass and speed of the invisible object. The one discovered in 2022 was about 7 times the mass of our Sun and was moving at 160,000 kilometers per hour. In short, a rogue black hole is a dark, massive nomad. They are not rare, they are just hidden. They represent a silent population of dead stars that continue to travel through our galaxy, affecting everything they pass with their invisible gravity. Now that we know what they are, the next question is, how does a black hole, one of the heaviest things in the universe, get kicked out of its home in the first place? One of the most common questions in astronomy is, how does a black hole, an object with the mass of several suns, begin to travel through the galaxy alone? To move something that heavy, you need an incredible amount of energy. In the universe, this energy usually comes from two sources: violent stellar deaths or complex gravitational interactions. The most frequent way a rogue black hole is created is through a process called an asymmetric supernova. To understand this, we have to look at how a stellar mass black hole is born. When a massive star reaches the end of its life, it runs out of fuel and can no longer support its own weight. The core collapses instantly, and the outer layers of the star are blown away in a massive explosion called a supernova. In a perfect scenario, this explosion would be symmetrical, meaning the energy goes out equally in all directions. If the explosion is perfectly balanced, the resulting black hole stays exactly where the star was. However, space is rarely perfect. Often, the explosion is stronger on one side than the other. This creates what scientists call a natal kick. Think of it like the recoil of a gun. When a bullet is fired forward, the gun is pushed backward. In a supernova, if more matter and energy are blasted in one direction, the remaining core, the new black hole, is pushed in the opposite direction. Because the energy of a supernova is so high, this kick can be extremely powerful. It can launch a black hole at speeds of hundreds of kilometers per second. This speed is often fast enough to break the black hole away from its original star system or the star cluster where it was born. Once it escapes that local gravity, it begins its long journey through the galaxy as a rogue. The second major way a black hole becomes a rogue is through gravitational interactions in dense environments. Most stars in the universe are not born alone. They're born in large groups called star clusters. In these clusters, thousands or even millions of stars are packed relatively close together. Inside these crowded clusters, gravity is constantly pulling objects in different directions. Sometimes, a black hole becomes part of a triple system, where three massive objects are orbiting each other. These systems are mathematically unstable. Over time, the two most massive objects will often move closer together, and their combined gravitational energy will slingshot the third object out of the system. This is similar to how we send space probes to the outer planets. NASA often uses the gravity of a planet like Jupiter to sling a spacecraft faster into deep space. In a star cluster, a black hole can be the victim of this same process. If it gets too close to a pair of even more massive objects, it can be thrown out of the cluster entirely. Once it leaves the cluster, there is nothing to stop it, and it becomes a permanent wanderer in the interstellar void. While most rogue black holes are stellar mass, there is another, much larger version of this process involving supermassive black holes. This happens during galactic mergers. When two galaxies collide, their central supermassive black holes eventually find each other and begin to orbit. As they spiral closer, they release a massive amount of energy in the form of gravitational waves. If these waves are emitted more strongly in one direction, they can actually push the newly merged giant black hole out of the center of the galaxy. In some extreme cases, the entire supermassive black hole, billions of times heavier than the Sun, can be kicked completely out of its galaxy. These are the rarest and most extreme types of rogue black holes, travelling through the vast emptiness between galaxies. How fast are these objects moving? Astronomers have measured some rogue black holes travelling at over 160,000 kilometers per hour. At that speed, you could travel from the Earth to the Moon in just over 2 hours. Because space is mostly empty, a rogue black hole can travel for billions of years without hitting anything. It doesn't have a destination. It simply follows the path set by the initial kick it received at birth. It will continue to drift until it encounters a significant gravitational field, like another star system or a gas cloud, which might slightly change its direction but rarely stops it. In summary, a black hole becomes a rogue not by choice but by force. Whether it is the violent recoil of an unbalanced supernova or a gravitational slingshot in a crowded cluster, the result is the same. An object that was once part of a system is now an orphan. These processes show us that the galaxy is a much more violent and dynamic place than it appears. Every rogue black hole we might find is a piece of evidence of a past catastrophe, a star that exploded unevenly, or a system that was torn apart by gravity. But if these objects are invisible and moving through the dark, how do we actually find them? In the next section, we will look at the technology and the clever methods astronomers use to track these invisible hunters. Finding a rogue black hole is one of the greatest challenges in the history of astronomy. Under normal circumstances, we find black holes because they are interacting with something else. They might be pulling gas from a nearby star which creates bright X-rays, or they might be at the center of a galaxy where they affect the orbits of thousands of stars. But a rogue black hole is different. It is alone in the dark and it does not emit or reflect any light. To our traditional telescopes, these objects are invisible. So the question remains, how do you find something that refuses to be seen? The answer lies in a phenomenon called gravitational microlensing. This idea comes from Albert Einstein's theory of general relativity, which suggests that gravity can actually bend the path of light. Imagine a rogue black hole travelling through the Milky Way. As it moves, it eventually passes directly between Earth and a distant bright star. Even though we cannot see the black hole itself, its massive gravity acts like a cosmic magnifying glass. It bends and focuses the light from the background star, making that star appear much brighter than usual for a short period. However, catching a microlensing event is incredibly difficult. Space is vast and these alignments are extremely rare. Astronomers have to monitor millions of stars for years, waiting for one of them to brighten in a very specific way. When a star brightens because of a black hole, the event lasts much longer than when it is caused by a smaller object like a planet or a dim star. Furthermore, a black hole is so heavy that it doesn't just make the background star brighter. It also appears to slightly push the star's position in the sky. Measuring this tiny shift requires the most precise instruments we have ever built. In 2022, after years of searching, scientists finally announced a major breakthrough. Using data from the Hubble Space Telescope, they confirmed the first ever discovery of a lone rogue black hole. The object, known as OB110462, was detected about 5,000 light-years away from Earth. Two different teams of researchers analysed the data for over 6 years to be absolutely sure of what they were seeing. They observed that a distant star had brightened for nearly 300 days and had shifted its position by a tiny amount. This evidence proved that an invisible object, about 7 times the mass of our Sun, had passed in front of it. This discovery was a turning point for astronomy because it proved that the millions of rogue black holes we predicted actually exist. The object they found was moving at about 160,000 kilometers per hour, which supports the idea that it was launched into space by a violent supernova explosion. While Hubble was the primary tool for this discovery, The James Webb Space Telescope and future missions like the Nancy Grace Roman Space Telescope will take this hunt to a new level. These new telescopes have much wider views and higher sensitivity, allowing us to find hundreds or even thousands of these hidden nomads in the coming years. Searching for these objects is more than just a scientific curiosity. Mapping the locations and speeds of rogue black holes helps us understand the true structure of our galaxy. It tells us how many stars have died and how much dark mass is floating around us. Every time we detect one of these invisible hunters, we learn more about the violent history of the Milky Way. We are finally beginning to see the ghosts that have been hiding in our galaxy for billions of years. But knowing that they are out there leads to a much more practical and frightening concern. If there are so many of these invisible giants moving through the dark, what would happen if one of them headed toward our own solar system? Now that we've confirmed that rogue black holes are real and moving through our galaxy, we have to ask a terrifying question. What would happen if one of them entered our solar system? This is the doomsday scenario that many people fear when they think about these invisible giants. The idea of a silent black void swallowing the Earth without warning is a popular theme in science fiction. However, the scientific reality of a black hole encounter is slightly different from what you see in the movies, though it is just as dangerous in other ways. To understand the danger, we first need to clear up a common misunderstanding. A black hole is not like a cosmic vacuum cleaner that actively sucks everything in from a distance. Its gravity works exactly like the gravity of a star or a planet. If a rogue black hole with the same mass as our Sun replaced the Sun tomorrow, the Earth would not be sucked into it. Instead, the Earth would continue to orbit that black hole exactly as it does now. We would freeze because there would be no light, but we wouldn't be swallowed. Therefore, the chance of a rogue black hole having a direct head-on collision with Earth is extremely low. The Earth is a very small target in a very large space. The real danger is not the black hole's mouth, but its invisible gravitational reach. Long before a rogue black hole reached the inner planets where we live, it would have to pass through the Oort cloud. The Oort cloud is a massive shell of billions of icy objects and comets that surrounds the very edge of our solar system. As the black hole passes through this region, its immense gravity would act like a bowling ball crashing into a set of pins. It would pull and push these icy objects out of their stable orbits, sending thousands of them screaming toward the inner solar system. We would find ourselves in a period of intense comet bombardment that could last for millions of years, making life on Earth incredibly difficult to sustain. If the black hole continued to move closer to us, the situation would become even more critical. It wouldn't need to touch a planet to destroy it. Its gravity would begin to pull on the orbits of the planets themselves. Our solar system is a very delicate machine where every planet's path is balanced by the gravity of the Sun and the other planets. A passing black hole could pull the Earth out of the habitable zone, which is the perfect distance from the Sun where liquid water can exist. If we were pulled even a few million miles closer to the Sun or pushed further away, our atmosphere would be ruined and life would end. In an extreme case, the gravity of the passing black hole could simply fling the Earth out of the solar system entirely, leaving us to drift as a rogue planet in the freezing dark of interstellar space. So, how worried should we be about this happening? To put your mind at ease, we have to look at the statistics of the galaxy. While there are estimated to be 100 million rogue black holes in the Milky Way, the galaxy is unimaginably vast. The space between stars is so empty that the chances of any object, whether it's a rogue star or a rogue black hole, passing through our specific solar system are very, very small. Most of these objects will travel for billions of years without ever coming close to another star system. The nearest rogue black hole we have actually confirmed, as we discussed earlier, is about 5,000 light-years away. To give you an idea of that distance, if you were travelling in the fastest spacecraft ever built, it would still take you tens of millions of years to get there. Astronomers also monitor the motions of the outer planets and the distant comets very closely. If a massive invisible object were currently heading toward us, we would likely see its gravitational effects on the orbits of Neptune or the objects in the Kuiper belt long before it arrived. For now, the consensus among scientists is that there are no rogue black holes close enough to pose a threat to us in our lifetimes, or even in the next several thousand years. We are safe in our corner of the galaxy. However, the fact that these invisible hunters are out there wandering the dark serves as a reminder of how lucky we are. Our solar system is a quiet island in a very dynamic and sometimes violent ocean. Understanding these dangers doesn't just help us prepare for the future, it helps us appreciate the rare stability that allowed life on Earth to begin in the first place. The discovery of rogue black holes reminds us that we are still in the early stages of understanding our own galaxy. For a long time, we thought of the Milky Way as a map made only of bright stars and visible structures. Now, we're beginning to realize that this map is incomplete. There are millions of massive invisible objects moving through the dark spaces that we once thought were empty. These rogue black holes are a reminder that the universe is far more crowded than it appears to our eyes. For many years, these objects were nothing more than a mathematical theory. Scientists knew they should exist based on how stars die, but they had no way to prove it. The discovery in 2022 changed everything. It shifted our perspective from wondering if they were out there to actively hunting for them. We now know that the ghosts of dead stars are a real and significant part of the galactic population. This shift in understanding is a perfect example of how science works. We take something invisible and, through patience and better technology, we eventually bring it into the light. As we look to the future, our view of the dark side of the universe will only get clearer. With new tools like the Nancy Grace Roman Space Telescope, we will stop finding these objects by accident. We will begin to map them. We will learn more about their speeds, their sizes, and their origins. Each new discovery will help us refine our history of the Milky Way and the violent events that shape it. We are moving away from a time of fear and mystery and toward a time of data and knowledge. It is easy to feel small or even afraid when we think about 100 million invisible black holes wandering the galaxy. However, the true lesson here is one of curiosity and resilience. The same laws of physics that created these rogue black holes also created the stars, the planets, and eventually us. We live in a universe that is constantly changing and moving. While these nomads are out there in the dark, they are simply part of the natural life cycle of the cosmos. In the end, rogue black holes represent the ultimate frontier for astronomers. They are the final pieces of the puzzle in our understanding of how stars live and die. We are lucky to live in an era where we finally have the technology to see the unseen. As we continue to gaze into the night sky, we're no longer just looking at the lights. We're now aware of the silent, dark giants moving between them. They've been there for billions of years, and we're finally ready to learn their story.